do a quick review, then we'll dive into some new stuff. All right, so we've talked about this. This is working good for everybody. We're going to come back to this when we start talking about z-scores. Okay. All right. One of the things that's kind of handy to have, hi Bria, your test is up here. So you may, because corrections are permitted and they're due Friday, so you may want to take it with you when you go today. Rule of thumb. What's a rule of thumb? Yeah, in general, a rule of thumb is just something that kind of works most of the time, right? Does it work all the time? No, but a lot of times it works. So, rule of thumb is, in general, look at this down here. In general, the standard deviation is basically the range divided by 4. Now, that'll work if there are no outliers. Outliners. I guess I need to fix the spelling on that. The N shouldn't be there. Okay? If there are no outliners, whatever an outliner is. Okay. So what's going to wind up happening is, in general, a standard deviation is you take whatever the range is, divide it by 4. What's the range? And it's not that thing next to the refrigerator. Oh, it could be, but not in this case. The range is your high number minus your low number. That tells you how much spread there is. You take whatever that spread is, you divide it by 4, and that's about what the standard deviation is going to be. About. Not guaranteed, but it usually works pretty good. If we take a look at the information we were working with on the wait times at McDonald's versus the wait times at Wendy's, okay, the range on the McDonald's was 6.9 minutes divided by 4. The range on Wendy's was 1.2 divided by 4. And if we compare these two, remember the 1.7 and the 0.3. Okay. If you take a look at the standard deviations, now remember we kind of guesstimated that this would be about 1.7 and this would be about 0.3. Do those exactly match? No. But if you've got some data and you've got to just quick come up with, well gosh, what's going on with this? A quick way to get you in the ballpark is take the range divided by 4. And that'll get you pretty close. Okay? Not perfect on either of the standard deviations, but not bad either. Okay, so real important, keep that in mind. That's a real popular question for quizzes, tests, final exams, because it's something that you can kind of keep stuck in your pocket and it works. It's quick. All right. Looking at buying a new car. Sorry, a 3-year-old car. New to you. Okay? And you do some research online. It's kind of fun to read up on the cars, see what all's going on. And you find this car that has a mean mile per gallon of 45. We're assuming that it's a normal distribution. How can you get that 45 miles per gallon? Well, you can read that right off of the internet. Or if you're at the dealership, how could you get it at the dealership without digging out your cell phone and messing around? This number is right there on the big sheet that they have pasted onto the window. It tells you the price and all the other stuff that comes with it and the final sticker price and all that. It's a big number at the top center. What is the estimated miles per gallon? They'll give it to you city, highway, combined. Okay? So you're looking at this car. Gets 45 miles to the gallon, and you happen to be on a site, I don't know, Auto Weekly, something or other. They're talking about the car, reviewing it, and down in the little fine print it tells you it's a standard deviation of 4 miles per gallon. And you're wondering, am I really going to get 45 miles to the gallon? Or what's it going to look like? What will my mileage look like? Okay, well, one thing is on the low end. What's going to be the worst? Now remember, one standard deviation is 68, 2 is 95, 3 is 99.7. Most of the time, 95% of the time, that's 2 standard deviations. If you're interested in 95% of the time, what's the worst you're going to get? What's the minimum? That would be 2 standard deviations. So to figure out the low value, you take whatever your mean is, 45 miles per gallon in this case, and you move over 2 standard deviations to the left. Now remember, the standard deviation is 4, and if we're going to move 2 of those, that means we're going to lose 2 times 4, or 8. Can fairly quickly figure out, well, gosh, about the lowest fuel economy I'm going to get is 37 miles to the gallon. Unless you're stuck in a big traffic jam on I-75 down in Kentucky. Seems like they've often got a big chunk of I-75 closed down to one lane, and there you sit for an hour. Okay? Does that make sense on how to get the low, estimating the low? You can play the same game then for the high. What's the high we can expect to get? If you're rolling down hills, gentle on the brakes, all the other good stuff, you would once again do the mean, which is the 45. Go out 2 standard deviations. Well, the standard deviation is 4. So you're going to do the 2 times 4, which will give you 8. High, 53. So what this tells you then is, under normal driving conditions, normal driving conditions would be anything from just driving in town, traffic stuff, to driving out on the expressway where it's flat and you've even got a tailwind. Okay? Your fuel economy is going to be somewhere between 37 and 53 miles to the gallon. Does that make sense? Real fair question on the quiz or test is to give you a mean and a standard deviation and ask you, hey, most of the time, what do you expect to happen? And that's really what these statistics are about, is so that you can say, hey, most of the time it should be, and you got some kind of an idea of what's going on. When you go to buy stuff like a refrigerator, you're going to want to research it. Refrigerator, really, Chuck? How much does a refrigerator cost now? An average whole home refrigerator is about $2,000. Oh, well, if you're going to drop that kind of money into it, you're probably going to want something that's going to last a while. So, last a while, what does last a while mean? Well, you start looking up things like this. Okay. And the whole idea of this class is to say, okay, so when you run across these numbers, how do you handle them? Okay. To help you make better decisions. Okay, so that's got that done. I want to keep the ink. Nope. Go ahead and close this. Aha, normal distributions. Now, we're in section 6C. Normal distribution is going to talk more in depth about that bell curve, because that bell curve is talking about a normal distribution, isn't it? Okay? So we're going to take a little bit more careful look at normal distributions. We've talked about the fact that it can be really tight, little variation, the weight of the bricks that are used to make the building. Wide variation, the amount of wear you get on a set of tires. Do you drive a lot of gravel or concrete, or do you drive mostly blacktop? Okay. Normal distribution is going to be that bell shape with one peak. This is important, one peak. Now the cool thing about a normal distribution is right smack dab in the middle, that specific value is going to be the mean, the median, and the mode, all three rolled into one. The idea of a normal distribution is the mean, median, mode all wind up in the same place, which is pretty cool. Okay. Does it always happen? No. On the test that you just had, okay, you were given some data where it was skewed one way or the other. We'll do this left skewed. And on this you were asked, well gosh, where's the mean, the median, and the mode? Now the mode is always easy to do. The mode is, where's the mode going to be? The top. The mode is the peak. So when you're asked where's the mode, you just look for the peak. The mean is going to be affected by the outliers. Well, with that thing being skewed left, the mean is going to be pulled over. So the mean is going to be somewhere like this. Exactly where? I'm just guessing. But somewhere around there is going to be the mean. Now, think about the word median. What does median mean? The middle. So where's the median going to be? It's going to be in between the other two lines. Always? Always. That's why it's called the median. Really? So you put your mode down at the high point. You pull your mean over whatever direction the data seem to be spilling. And then in between the two of them, you put your median. And that's really all there is to it. Whoa, hopefully that one suddenly became real easy for, I think, 3 points on the test. Okay, so if you didn't get it the first time, you can pick it off with the corrections, if that's one you choose to go after. Your call. All right, so let's take a look at some data. Two different sets of data, kind of odd sets of data, but hey, what's the point of always talking about tire wear? That's a little boring. Okay? The one on the left is kind of interesting because this is based on military information from back in the 1800s. This is information about the Scottish Army. Okay? And it's the average chest circumference of the Scottish Army back in the 1800s. Kind of handy to know what size uniforms to make, right? Ah, yeah, I guess. Okay. So, how many inch circumference did the average guy in the Scottish Army have at that point in time? Well, it may be kind of hard to read. Here's 39. And let's see, this would be about 40. So the average guy had between a 39 and 40 inch chest. So you take a 39 or 40 in a suit size. .41's over a little bit, and you get the idea. Is that a set of data that's fairly normally distributed? You can look at it and you can see there that it pretty much looks like a bell curve. Does that have a lot of variation or is that fairly tight? Not much variation there. So would the standard deviation be very large or a fairly small number for that data? Be pretty small. Okay. On the other side, we look at, or we have data about various residential areas. And what this is talking about is the population density, people per square mile. There are lots and lots and lots of places with not many people per square mile. These are going to be like little towns and villages and stuff like that you see when you're driving the back roads. There are a couple, not many places, that have a whole bunch of people per square mile. What would be an example of something like that? Maybe something like New York, Los Angeles, Chicago. There are very few cities like that around, aren't there? Okay. High density, not many. Lower density, whole bunch of them. This would be a data set that is this skewed right or skewed left? Which way did it get pulled? To the right, so it's skewed right. Okay. If you were asked on something like this, where the mode is, where's the mode? Wouldn't the mode be over here? The mean is going to get dragged over this way some, because it's going to be pulled over due to the high densities. And where's the median going to be? Where it always is, in the middle. So that gives you that. Computer really wants to get to the next slide. Is that making sense? You okay? Okay. What are some conditions that you have to have for a normal distribution? Well, first off, most of the data's got to be, hey there, I'm glad you made it. Most of the data's got to be kind of crunched in the center. And this is important, it's spread evenly. That means on both sides, it's not skewed. Okay? Big deviations are rare. But you will get some changes. You will get some deviations. One of the things that's kind of common is IQ. Now, IQ is one measure of intelligence. It doesn't include everybody and every type of intelligence. Okay. But IQ is one that is fairly normally distributed. Bell curve. It's like what's thrown up there. What is the mean IQ? What's the average? Most of the people you bump into, IQ about 100. What's the standard deviation? About 10. Okay. So if you come out to 110, and go over this way to 90, as you're bouncing around today, stopping at Speedway or wherever, most of the people you bump into are going to have an IQ between 90 and 110. In fact, what percent of the people are going to have an IQ between 90 and 110? About 68%. Does that make sense? If you come out another one, 80 and 120. That's going to be what percent of the people? 95%. Is that making sense to you? If we crank it out a little further, come up to say 130 and down to 70, of the people you encounter today, what percent of them are going to be between 70 and 130? 99.7. Yeah. Now, here comes the tricky part. We got to think in the other direction. So far, that's accounted for, I think it's 10. check that. That maybe a little wider on the standard deviation. Maybe more like 15. Okay, but let's run with 10 for right now. 99.7% of the people are in that grouping. Now, outside of that grouping are some people over here and about an equal number of people over here. Between those two tail sections, that's what percent of the people? It's 0.3%. If you take both tails, well, how'd you get 0.3%, Chuck? Well, I got three. Can't put microphones here. You get the 0.3% because we've already got 99.7 accounted for, don't we? What's left? The 0.3. Now, if 0.3 is left and half of it goes each way, it's going to be 0.15% over here and 0.15% over there. Does that make sense to everybody? Which means that if you meet 1,000 people, there'll be one person that's to the far right and one person to the far left out of 1,000 people. Okay. So running into folks that are either way over here in the 140 and the 150 and stuff like that is pretty uncommon. Running into folks over here that are in the 60 and the 50 range is pretty uncommon. Oftentimes people in the 50 range, they really are not at a level where they can function well on their own. So oftentimes they're being taken care of because they just really can't function on their own. Okay. So the likelihood of you meeting somebody in that range is unlikely in your normal day-to-day travels, unless your normal day-to-day travels include care facilities, something like that, because folks are they're going to be in trouble. Make sense? I know I keep coming back to the 68, 95, 99.7. It's on purpose because you really need to retain that for this class, and it's kind of handy to keep in mind just for general stuff. Okay. SAT scores. Mallory, would you be willing to the door? Thank you very, very much. SAT scores. Are they the predictor and the one thing that'll let you know how well you're going to do in college? The answer is no. Are they the predictor and the number one thing that's going to tell you how successful you're going to be in life? Once again, no. It's just a measure of some areas of knowledge. Okay? The mean, 500. Standard deviations are in groupings of 100. Okay. Not sure what your SAT is. I'm not even asking. Some of you didn't take the SAT. Some of you went with the ACT. Okay. So you've got something like 18, 20, 25, whatever you got. Okay. But the objective on things like the SAT, the ACT is a different set of numbers, but it's still distributed the same, is to group folks. Okay. Now, we've talked about that. Here's where I want to get to today. Z-scores. One of the questions that often comes up is, if I got a particular score, or as you move to the next phase in life, if my kid got a particular score, how well did they do? On standardized tests, okay, in our school district, they mail out the results to us. Let's see how the kiddos are doing. And what they'll do is they'll give you a score. I don't know, maybe a 37. Well, great. What's a 37 mean? Well, that's a z-score of 1.8. Now, for some folks, well, great, 1.8, I don't know what that means. That's no better for me than the 37. I don't want you to be those folks. Z-scores are very easy to compute and understand, and you will run into them. I've never run into them yet. Yeah, well, you got a lot of life ahead of you. And it's going to get more interesting. It's going to get more fun. It's going to get more exciting. Okay? And this is funny. Okay? My daughter, the other day, made the comment. She said, you know, when I was in high school, I thought I was busy. And now I look back at all the free time I had in high school. And my comment to her was, and honey, enjoy college, because when you get into real life, you're going to look back on college and enjoy all the free time you had in college. She looked at me like a three-headed beast of some sort. Okay? It gets busier. Okay? Honest. I get up a little after 5. I get to bed about 11. And when I get up, it's and away I go, and the next thing I know, it's bedtime. 11 at night. Okay? And it's okay. It only goes that way for decades. Okay, so let's look at this z-score stuff. How do you compute a z-score? The idea of a z-score is to tell you how far away you are removed from the mean. It's to give you a measure of how far removed you are in one direction or the other. There's sometimes you want to be high, sometimes you want to be low on the direction that you're removed from the mean. But what you do for a z-score, or it's also called a standard score, is you take whatever the value is. So let's say SATs. Let's say you got an SAT of 583. And the question is, well, is that good or bad? Well, it's good. It's above the average. Wait a minute, Chuck. Don't give me this average stuff. I know there are 3 types of average. It's above the mean. Recall from the previous slide, it stated that the mean was a 500 and the standard deviation is 100. Okay. With that information, we could look at computing a z-score. The z-score is going to be what you got of 583 minus the mean of 500 and you divide it by the standard deviation of 100. Well, these numbers are kind of nice to work with. What this gives you is a 83 over 100, which is a 0.83. Well, okay, a z-score 0.83. Well, that's nice. That's great. What do I do with that? There are charts that are published that you can go to look up what a specific z-score means. Here's one of them. Aha! An eye exam. Great, Chuck. Just what I wanted. Okay. Now remember, on the SAT score, on the score that we made up, the z was a value of 0.83. And the question is, okay, where does that place you as far as all students who are looking at getting into college? Is a z-score of 0.83 enough to get you a free ride? Or maybe it's enough for a partial scholarship. Or at least it's enough to guarantee that you're going to get in. What is it? What you do is you look up whatever the z-score is. Well, if you look down here, here's 0.8 and 0.85. There isn't 0.83. Aha, that means we're in between those two, aren't we? Once you find the z-score you're interested in, you look over and it gives you the percentiles. It's somewhere between 78.8 and 80.2. Now, if you took kind of in the middle of that, that would percentile-wise So just kind of guesstimating about 70, let's say 79.3 percentile. Okay, so of 79.3 percentile, what does that mean? Well, if you were to look at a normal distribution curve, and remember, we are talking about normal distributions. If you look at a normal distribution curve, it would say you're at the 79th percentile. Well, remember, 68 is here, 95's like that, so 79, that's close to 80. That's right about there. That says that your score is better than about 79% of the people. That puts you in about the top 20%. Oh, okay, now I get it. A z-score of 0.83, that's about the top 20%. Is anything to be embarrassed about? No. Especially when you start looking at a more selective group like folks going to college, because you've already cut out a big chunk. Okay. I have to keep reminding Lauren of that. She's in engineering school, and she's angry that, well, frustrated, that she's not the top smartest person in the engineering school. I keep reminding her, honey, they brought in people from all over the world, the best. Just being in the group is good enough. No, Dad, I've got to... Fine, whatever. Okay. This puts the person in the top 20%. Does that make sense how to do the z-score? Now, the thing I want you to remember is, or one of the things, these z-scores are real easy to do. They are really easy to do. You take whatever your number is that you've been given, you subtract the mean, and you divide by the standard deviation. Whoops. Okay. That's all you do. You take the data point you have, you subtract the mean, divide by whatever the standard deviation is, and once you get that value, you then go to a standard score, percentile distribution, or a z-score table, or whatever, and you look it up. Is it possible for z-scores to be negative? Yes. Okay. It is possible to be negative. That means that somebody is in the lower percentile. Okay. My kids are in a very low percentile. I go to the doctor, they ask, do you guys ever have any food around your house? Okay. When my kids were little, they were in like the 4th percentile weight-wise. And honest, we're dumping it in, we're pouring it in, don't know where it's going or what's happening to it. Okay? Becky is, well, about like me. Poor kids, they didn't have any chance, did they? Okay? So what winds up happening is our kids, weight-wise, are really low percentile. Frustrates Daniel greatly now that he's in high school playing varsity sports. He doesn't want to be the skinny kid. Sorry, that's what you got. Okay? So sometimes being on the low end is good, sometimes being on the high end is good. Sometimes being in the middle is good. Okay? Gentlemen, I don't know if you've ever thought about it. Pants, 32, 36. Good luck finding them. Sometimes being in the middle is nice. If you're like a 34, 32, you can buy anything you want. Suits. It's a pain for me to buy suits. Chest size, about 43. Waist size, 32. That's an 11-inch drop. Good luck trying to find one. It'd be a whole lot nicer to be in the middle. Sometimes. I'm not complaining. Okay? So what winds up happening is sometimes being in the middle is good. There's nothing wrong with being average. Depends on what it's about. Okay? Does it make sense on how to do z-scores? Okay. Uh-oh. cholesterol level is about a 178 with a standard deviation of 41. Okay, so somebody goes in, gets their cholesterol checked. They're 20 years old. Okay, so they're in this grouping, and they have a cholesterol level of 190. Is that good, bad, or what's the deal? Are they on the verge of a heart attack? Or is it pretty much just average and go ahead and enjoy the biscuits and gravy for breakfast? Well, one of the ways to determine it is to first compute the z-score and compute what percentile they are in. If you're in the middle, fine. So to compute the z-score, recall you take the number that you've been given minus the mean, and sometimes the mean will be bigger. If the mean is bigger, that just means it's bigger. That just means in whatever this is, that person's value is, score, is below average. Okay. Divided by the standard deviation, 41. So this is going to give us 12 over 41. So if we do the 12 divided by the 41, it gives us 0.29268. Now folks will get concerned and, well, gosh, Chuck, how many decimal places do I need to include? Look at the z-table you're using. If it only goes out 2 places, do you really need 5 decimals? No. Okay, so let's take a look at this. We've got a 0.29. 0.29. First off, realize this cholesterol score is a little higher than average, isn't it? A little higher than the mean. This person's on the high side. Okay? So maybe they shouldn't be eating fried lettuce. Just eat the lettuce green. Let's go back. There it is. Let's look up the 0.29. 0.29 is going to be in this range. Clear some of these others out of the way so that you can see what we're focused on here. Percentile-wise, where are they going to be? About 61. So about the 61st percentile. That means that their cholesterol level is higher than 61% of the people, isn't it? It's lower than what percent? Let's see, if they come over the 61, there's some folks above them. How many folks are above them? Let's see, 61 are accounted for out of 100. I guess there's another 39 that are higher. Okay. So is this person, are they okay and great to go and all that, or maybe raise the eyebrow a little bit? Yeah, this is maybe a raise the eyebrow a little bit sort. It's not time to take extreme measures, but it'd be nice to get it down a little bit. Okay. Went in for a checkup Monday. Blood pressure is 96 over 64. What's that say? It's lower than normal. Is that a good thing or a bad thing? Well, what's normal? 120 over 80. There you go. Okay, so that's not bad. You want your blood pressure, why do you want your blood pressure a little lower? Because they said so, whoever they is. It puts less stress on your heart and on all your blood vessels. Okay? The higher the pressure, the more your heart's got to work against and the blood vessels have to contain. Okay, heart rate. Resting heart rate is, wound up being about 50. High, low, or average? Low. there are some examples of places you want to be low. Hoping that translates to people are going to have to put up with me till I'm 98 or something. Maybe 100. Who knows? We'll see. Okay. Second question here. What cholesterol level would put you in the 90th percentile? Ooh. 90th percentile. The first thing we want to figure out here is, okay, so what Z-score would put us in the 90th percentile? Well, for the 90th percentile, here it is. Here's the 90th percentile. If you're going to be in the 90th percentile, what's the Z-score you need? 1.3. Okay, so we need our Z-score to be a 1.3. And what we're going to do is we're going to plug in the numbers that we know and then figure out the ones that we don't know. Well, we know the standard deviation is 41. We know that the mean is 178. Do we know what the cholesterol level is that'll give us that? No. That's right here. Now, in math, instead of putting a question mark there, what's the squiggle mark that they use there instead of a question mark? X. Okay. And then just solve for X. Oh no. What are you going to do first to solve for X here? Yeah. So we're going to take the 1.3 times 41 equals, and that'll give you 53.3 equals X minus 178. Now, to get X, or this cholesterol level, what are we going to do? Add the 178, yeah. So we're going to do plus the 178 equals, and you're going to say, oh my gosh. Cholesterol level of 231, is that good news, or you all recognize that as, we got problems here, okay? That means that their cholesterol is higher than 90% of the people in the country for guys in that 18 to 24 year group. Does that make sense how you can run this stuff both ways? Okay, we will finish this out on Friday. Friday there will be a quiz. Yeah. Okay, that answered your question. The quiz on Friday is going to be some fairly straightforward stuff like doing standard deviations and the Z-score stuff. Okay, and that's basically all it's going to be on the quiz. Yeah. Okay, yeah, for January on the budget you need $1,000, and then February you've got another $1,100, and what if you don't have another $1,100 in your emergency fund? You go to the hospital and you talk to them. Now, some of you may want to do the strategy of put it on your credit card, because the credit card is what percent? 18, but the hospital is charging what? 21. Oh, But you got to get it run somewhere or another. We'll talk more about that.